he was involved. This is around the time of the French Revolution, I think, and he was involved in politics. And some people say that he was set up because of his politics and killed because of that. But the night before the duel, he basically knew that he was going to be killed at this duel, and so he spent the whole night writing this letter about the mathematics he had been thinking about. And they still have this letter. It's incredible. It's like scrawled. It's furiously scrawled. And you could see that he was trying very desperately to get everything out. But this last letter basically influenced mathematics, the formation of group theory. Those of you who've taken 171, group theory is basically what arose in response to trying to understand that last letter and make it rigorous and establish the results that he sketched out. So that's group theory. And then 172, I think, is Galois theory. Well, why is it called Galois theory? Because it's all based on this guy's work. So, how old are you guys? How much time do you have before you need to do something that will affect mathematics for the next 100 years? It's too late for me, but it's far too late. But you guys, you should set that as your goal. By the time I'm 21, I'm gonna do something that professional. Okay. Okay. Yeah. Sorry that this. Okay. So I find it a little bit hard to get excited about this stuff. But so how do you find roots of a polynomial like this? Maybe you guys know the trick. Do you guys know the trick? What's the trick? You look at the factors of the first coefficient and the last coefficient. You guys see this? Right. Okay. So you consider. It turns out that if there is a rational root, it must be of the form p over q. If there is a rational root of this guy, then it must be of the form p over q, where p is a divisor of 4 and q is a divisor of 2. So you look at the divisors of the last guy, and you look at the divisors of the first coefficient. And so you say, okay, well, right, so p has to be plus or minus 1, plus or minus 2, or plus or minus 4. Right? Q could be plus or minus 1 or plus or minus 2. Right? And so you look at everything that is in the form p over q, like that. Right? You look at 1 over 1, 1 over 2, 2 over 1, 2 over 2, 4 over 1, 4 over 2. Right? Like half, 1, half, and 2, plus or minus. Right? And then you try those. It turns out that if there is a rational root, then it will be of this form. You try those by trial and error, I'm afraid, and you end up seeing that you see that that 2 is a root. Yes.
Would this be easier by factoring 2 out? I mean, I guess that would be hard to use this method, but like if you factor the 2 out.
Yeah, that would be good actually. Yeah, that would actually simplify. Yes. Okay, and then once you see that 2 is a root, you can divide out, right? You say, well, I know that lambda minus 2 is going to be a factor of this thing. Right? So 2 lambda cubed minus 4 lambda squared minus 2 lambda plus 4. Right? And you just do long division, right? And you get 2 lambda squared. Right? You get 2 lambda squared, so you get 2 lambda cubed minus 2 lambda squared, right? Subtract, you get minus 2 lambda squared. No, I'm sorry. Sorry, this should be 4. Yeah. So you get 4 lambda squared. Right? That becomes 0, you get minus 2 lambda plus 4, and so you get minus 2 minus 2. So you get minus 2 lambda plus 4. Right? And so you get that this thing you can write as lambda minus 2 times 2 times 2 lambda plus 1 lambda minus 1. And so that gives you this. Right? So either 2t, either t, either minus t is about 1 set. So you see that the game is basically getting more root, being able to solve these polynomials of high degree. Okay, that's all I'm going to do. Sorry.